Earth, a unique planet, restless and dynamic. Continents shift and clash. Volcanoes erupt. Glaciers grow and recede. Titanic forces that are constantly at work, leaving a trail of geological mysteries behind. This episode explores Yosemite Valley, a magnificent 3,000-foot deep canyon. Traveling through time, scientists are unlocking deep secrets trapped inside these granite walls. These rocks have literally been to hell and back, frozen, drenched, and battered by earth-shattering forces. One more chapter in the incredible story of how the Earth was made. In the foothills of the mighty Sierra Nevada, California, lies a valley like no other on Earth, Yosemite. A 7-mile-long, 1-mile-wide granite canyon. Here lie some of the most awe-inspiring geological features on the planet. Half Dome, America's most iconic peak. Yosemite Falls, the highest unbroken waterfall on the continent. And El Capitan, one of the biggest sheer cliffs in the world. The Europeans discovered this astonishing valley only 150 years ago.
These sheer walls and granite cliffs and high waterfalls was a marvel to them as it is to us.
Ever since it shot to fame, Yosemite has been shrouded in mystery.
It's almost as if there was a higher power at work that basically said, that looks really good right about there, and then just put a little bit of grass right there, and put some oak, like an oak woodland right through there, and that's it, that's perfect. Because it doesn't seem like anything was haphazard. It seems like this was designed to overwhelm and to leave people awestruck.
Yosemite's unique design has intrigued scientists for centuries.
I think when you see something that's this dramatic, you just have questions. And the question is, how did this happen? How did you get monoliths, these huge stone structures that are just rising thousands of feet off the valley floor? How does that come to pass? And for over 100 years, people have been trying to answer that question.
The story begins in 1870, when amateur geologist John Muir went hunting for the answer. Founder of the Sierra Club, he funded his obsession with the valley by herding sheep and writing articles about Yosemite. He wrote that no temple made with hands can compare with Yosemite. Muir scoured the landscape for clues as to how this unusual box-shaped canyon formed, and came up with a radical, seemingly far-fetched theory. He believed that the world's climate was once extremely different, and the lush canyon where the Merced River flows was filled by a gigantic glacier, thousands of feet thick. Muir proposed that as this river of ice slowly flowed downhill, over thousands of years, it gouged a deep canyon and sliced vertical cliffs into the granite walls. But that controversial idea brought him into conflict with a fearsome opponent, the admired California state geologist, Professor Josiah Whitney.
Josiah Whitney did not have much respect for John Muir because Josiah Whitney was a state geologist, and at that time, John Muir was herding sheep. Certainly he's thinking, what does this man know about this range? How dare he?
Whitney believed that this unusually square, steep-sided valley could only have been formed by a sudden, cataclysmic event. He was adamant that giant cracks in the earth caused the valley to pull apart and dramatically sink, cleaving steep cliffs as it fell. This bitter Whitney-Muir conflict raged on for decades, but now scientists are hoping to figure out this complex puzzle once and for all. The first stage of the investigation is to understand how the rocks themselves were created. The canyon is made almost entirely of Yosemite granite, one of the hardest rocks in the world. To understand how this formed, scientists must travel back in time to the beginning. It's 250 million years ago, and the landscape is very different. Dinosaurs roam the land and dominate the skies. An incredibly rare remnant of that time has been discovered northwest of the valley at Mount Hoffman. This patch of softer reddish rock is the oldest in the park. It's sandstone, and it once covered the entire region.
This rock is very different than most of the rock in Yosemite. It's much darker in color. It's got a different texture. This was originally a sedimentary rock that was deposited in layers.
On an ancient shore, sand and sludge compacted together, and over millions of years formed this sandstone. This tranquil landscape was transformed by an earth-shattering event deep below the surface, and the evidence lies here in the rock.
Here we have this older, layered sedimentary rock. You can see that many layers and banding, which continues across over into here. But strangely, this section of granite has cut right through the sedimentary rock and split this section in two.
How this unusual rock formation formed can be explained by a simple experiment using sand and wax.
This red wax here represents granite. The sand represents sedimentary rock. And right now I'm heating it to see what's going to happen when the wax melts. Actually, I start to hear some, oh, here it goes. We're actually getting a little bit of the wax pushing up through the sand, and the molten wax is lighter, and so it's pushing its way up through the sand, which represents the sedimentary rock. Yep, there's some more.
It proves the only way granite could have cut through this sandstone is if it was originally molten and able to flow like a liquid.
Molten rock forms deep within the earth, rises up through the crust, and in this case, forced its way through a crack, expanding it open, and then cooling and solidifying to form this band of granite.
This band of granite tells scientists that Yosemite's cliffs were once molten and heated to 1,800 degrees Fahrenheit.
95% of the rock in Yosemite is granite, and I can see with the naked eye all the crystals in here. They're fairly large, and that tells me that this rock cooled very slowly.
Scientists were now on the hunt for what was generating all this molten rock. The investigation led them to Mount Gibbs, another unusually colored mountain in the northern reaches of the park. It lies above a layer of granite and is made from reddish-gray rock. Strangely, these rocks were also once molten.
Here I have a rock from Mount Gibbs, and I can see that most of the crystals are very, very small. Most of them I can't even see.
These small crystals tell an incredible story. When molten rock cools quickly in the open air, crystals don't have time to grow.
And what that tells me is that this is a volcanic rock that was spewed out at the surface.
It is 200 million years ago. Volcanoes shatter the tranquil west coast. The earth explodes with molten rock. For the next 100 million years, lava pours thick and fast onto the land, covering the sandstone in volcanic rock 10,000 feet high. It stretches for 400 miles along the coast. North America's greatest mountain chain, the mighty Sierra Nevada, is forming, and the area that would become Yosemite is caught right in the middle of it. But some of this rising molten rock never makes it to the surface. Trapped beneath the blanket of mountains, it cools slowly, creating a giant chamber full of solidifying granite 2 miles below the surface. 400 miles long, 60 miles wide, and 5 miles deep, it stretches along the entire spine of the Sierra Nevada mountain range. Yosemite's immense granite monoliths were forged in a fiery furnace 2 miles below ground.
100 million years ago, I would have been standing in a vast chamber of molten rock with rock rising thousands of feet above me.
Scientists investigating how the rocks at Yosemite formed have found Bands of granite evidence Yosemite's rocks were once molten. And volcanic rocks, proof that the granite formed deep beneath the earth. But scientists were still mystified. Yosemite granite is so strong, it's unlike granite anywhere else on Earth. For hundreds of years, they tried to solve the mystery, while the answer was actually staring them in the face. 250 million years ago, Yosemite's landscape was a peaceful coastal plain. Now the investigation moves to 100 million years ago. The land that would become Yosemite is in turmoil. Volcanoes dot the skyline, spilling mountains of lava onto the land. And entombed beneath 2 miles of volcanic rock lies Yosemite's molten granite. The next 10 million years is a critical period for the rocks of Yosemite. Something unique is happening to the granite, making it tough enough to hold up cliffs 3,000 feet high. The search for the secret of Yosemite granite's immense strength led scientists to the biggest steep-sided granite block in the world, the mighty El Capitan. Twice the height of the Empire State Building, over 3 billion cubic feet of rock rises into the air.
El Capitan is the largest granite monolith in Yosemite National Park. 3,000 feet of pure granite. It's one of the biggest cliffs in the world. When I look up at something like this, I really want to hang on to the rock because I feel like I'm going to fall backwards with vertigo. Amazing.
El Capitan is the ultimate big wall climb. Once considered impossible to conquer, it's a treacherous ascent up a vertical, near featureless rock face with only a handful of routes to the summit. Sheer granite walls are normally unstable and over time get pulled down by erosion. So it was a mystery how rocks could hold up cliffs this big. Scientists are sampling the rocks to find out, but the Yosemite granite doesn't give in without a fight.
Whew. These Yosemite granites are really hard. You can work up quite a sweat trying to collect a bag full of this stuff.
Buried within this rock is the secret to Yosemite granite's success.
Oh, finally. Well, one clue to why these rocks are so tough is given by this sample right here. These are really large crystals. Large crystals make a rock really strong. They kind of weld together and they're flawless and they give a rock a lot of strength.
But it was a mystery how these tough crystals got so large and created such flawless rocks. This is in contrast to normal granite, which, when it cools, forms a hard rock with a fatal flaw. Riddled with cracks, these rocks are vulnerable to erosion.
If you take anything and it's very hot and you cool it quickly, it'll shatter. In granite bodies that cool quickly and form a lot of cracks that weaken the rock body and make it unable to support 3,000-foot cliffs. If you walk up to a typical granite and look at it, you'll find cracks 1 foot apart, 2 feet apart. You walk up to El Capitan, you might have to go 100 feet or more between cracks in the rock.
Clearly, something different happened here 100 million years ago.
El Capitan is really just one large, uniform, essentially faultless piece of granite, and that makes it very difficult for erosion to deal with.
For many years, it was a puzzle what had caused Yosemite granite to form so differently. But the secret had been staring scientists in the face.
One of the things you can see is a clue as to how this landscape formed in that dark diagonal splotch. That's called the North American Wall because that dark blob looks like, with some imagination, a map of North America, and you can kind of see Baja California sticking down on the left side there, and Alaska up to the northwest. And it's made up of a much darker, finer grained rock like this.
This dark granite is not just a map of North America. It's a window into the unique events that happened inside the Yosemite granite when it was buried deep beneath the earth.
And it's a younger body of granitic rock that filled a crack within the main body of El Capitan granite.
100 million years ago, the main body of granite cools and begins to harden beneath the earth. But then fresh, molten rock invades a crack and injects it with a blast of heat. The granite now takes 10 times longer to cool. Huge, robust crystals form and reseal the defective cracks. Time after time, fresh molten rock invades old, remelting and welding the Yosemite granite, creating gigantic shatterproof blocks which now tower thousands of feet into the air.
Given that these are obviously very strong rocks, it puts the Whitney-Muir controversy in an interesting light, because Whitney wanted the rocks to have broken and for the valley to have fallen down in between a couple of major cracks. Muir wanted the whole thing to be carved by glaciers, and both of those seem really difficult given how strong these rocks are, and yet behind me here is a 3,000-foot deep valley. Something carved it.
In the search to understand why Yosemite granite is so strong, scientists have found large granite crystals welded together to form a tough, flawless rock, and the North America Wall, evidence that Yosemite granite was reheated time after time, creating huge, faultless blocks. 100 million years ago, Yosemite's granite lies buried beneath a volcanic mountain range 2 miles high. Rivers slice into this soft volcanic roof, gouging and washing it away. Then 60 million years ago, when dinosaurs are no more, the featureless lump of Yosemite granite is finally exposed to the elements. But Yosemite's ultra-tough granite defies attack. For another 50 million years, it remains unscathed. It would take a catastrophic event to chisel the 3,000-foot canyon out of one of the toughest rocks on Earth. Yosemite's Merced River meanders in a 3,000-foot canyon. But 250 million years ago, no vast canyon stood here. Yosemite is a flat coastal plain. It is blasted by volcanoes, and its granite is buried beneath 2 miles of volcanic rock. When the Yosemite granite is finally exposed, it is a shallow, run-of-the-mill river valley. For a staggering 50 million years, it defies the destructive powers of erosion. If scientists were going to solve the mystery of how Yosemite Valley formed, they'd have to investigate the pivotal moment 7 million years ago, when a 3,000-foot canyon was suddenly chiseled into the granite, one of the toughest rocks on Earth. A clue to what almighty force overpowered the Yosemite granite lies high up on the exposed cliffs. Strange, deep cracks running for hundreds of feet through the rock.
Yosemite's granites are strong, but they're not always strong. I'm standing on a fin of rock between 2 deep fissures. These cracks run right across the Yosemite landscape, and they clearly formed after the granite formed. And if I look at their orientation, they all go to the northeast.
Strangely, Yosemite Valley is also oriented along the same northeast-southwesterly direction. Perhaps these cracks were the remnants of a cataclysmic rock-splitting event, as Josiah Whitney had predicted. A respected Yale-educated scientist, he passionately believed titanic forces beneath Yosemite had pulled the land apart, causing it to collapse along gigantic fault-line cracks. Could it be that the argument was swinging in the bombastic Whitney's favor, And Muir's glacial theory was the rambling of an ignorant shepherd after all. Scientists searching for the answer to how these giant cracks formed used modern technology to take a closer look at the ground beneath the Sierra Nevada. They did not find evidence of Whitney's cataclysmic rifting valley, but discovered a catastrophic event which had ramifications on a far greater scale. Seismic evidence has revealed that the Earth's crust is made of layers. The lighter outer shell forms the land, but fastened beneath is a dense anchor of sturdy rock. And beneath the Sierra Nevada, scientists discovered something extraordinary. A huge section of this lower crust, 200 miles long and 40 miles wide, is missing.
This model represents the Sierra Nevada as it looked 10 million years ago. So the top here represents the mountain range. The bottom there, it represents the lower crust. Sometime in the past 10 million years, part of that lower crust disconnected from the mountain range and dropped away. The end result is that there was uplift of the Sierra Nevada because they were being held down by those dense rocks. So there was uplift of the Sierra Nevada, but because most of the route fell away to the east, the whole mountain range, rather than bobbing straight up, tilted to the west.
7 million years ago, a huge chunk of the lower crust suddenly drops away. The entire mountain chain snaps along its spine and tilts upward. Finally, here is a force capable of overcoming Yosemite's ultra-tough granite. As it snaps, the enormous pressure cracks the solid granite along the entire length of the mountain range. But it was a mystery how these cracks could give rise to a 3,000-foot deep canyon. Scientists realized some other force must have attacked the weakened, vulnerable granite. The hunt was on for an accomplice. And 5 miles downstream of Yosemite, at El Portal, they find it. Rapids. Here, Yosemite's meandering Merced River has transformed into a raging torrent. At times, 1,000 cubic feet of water gush through this narrow gorge every second, creating treacherous waves and turbulent eddies.
So this is the Merced River about 5 miles downstream of Yosemite Valley. It's extremely powerful. It's a series of rapids and cascades over these boulders, and there's a lot of energy being expended by this river right now.
Scientists realized this ferocious force, combined with the rock-weakening cracks, even had the power to cut into Yosemite's granite.
The erosion of the river is focused right along the riverbed, and so it will cut down like a saw blade into the rock about the width of the river. So as it does that, it will come down and steepen the valley walls. Those walls will become unstable, and there'll be landslides into the river. The river will wash away the material, and you'll be back to that V shape.
Scientists realized if the Merced River created this deep V-shaped canyon, then it could also have cut a deep Yosemite Valley. "7 million years ago, as the Sierra Nevada tilts upwards, the mountain slope gets 3 times steeper, and the western flowing Merced River surges with a torrent of water. Like a saw blade, it zigzags along the path of weakened, cracked granite. In less than 5 million years, it cuts a 3,000-foot shaped canyon, running straight through the heart of Yosemite. Scientists investigating how Yosemite's deep canyon formed have discovered strange cracks in the rock, proof that the uplifting Sierra Nevada weakened the granite. And rapids downstream, evidence that the Merced River cut a deep V-shaped Yosemite canyon. But one part of the riddle remained unsolved: Yosemite's unique box-like shape. Some other extraordinary force had caused the canyon walls to collapse and the valley floor to flatten. The controversy about how this strange canyon formed raged on. Yosemite has had a turbulent past. 200 million years ago, its coastal plain is shattered by volcanoes. And then, 7 million years ago, the Merced River suddenly carves a deep V-shaped Yosemite Valley. For the next 4 million years, the river runs in this narrow canyon. But then, Yosemite is radically transformed again.
About 2.5 million years ago, when our ancestors were beginning to evolve in Africa, the V-shaped valley that was here began to evolve into the present valley floor, which is flat and is bounded by these vertical sheer rock walls on its side.
It was during this second extraordinary stage of cliff formation that the most iconic rock in America formed: Half Dome. This natural wonder's unique shape has intrigued people for centuries. Its enormous granite dome is over 3 billion cubic feet in size, as large as 1,000 football stadiums. And its striking northwest face is a 2,000-foot vertical drop. In 1870, amateur geologist John Muir had a radical theory about how Half Dome and Yosemite's other vast cliffs formed. He believed that thousands of years ago, the Earth's temperature had plummeted and the valley had been filled with ice.
You know, one thing that's important to keep in mind about John Muir, he didn't come up with this idea overnight. He was trekking, hiking, walking, going up to the tops of mountains. And the entire time he was doing this, he was listening, he was seeing, he was feeling, he was touching. And so he was slowly, letter by letter, word by word, learning the language of Yosemite.
Muir knew from research in the European Alps that glaciers were capable of gouging out solid rock. As these great rivers of ice flow downhill, they press down on the canyon walls with a weight equal to 200 trucks per square yard, ripping out chunks of rock and causing the valley walls to get steeper.
In general, glaciers transform a V-shaped valley that we see as characteristic of a river into a U-shaped valley by focusing their erosion on the valley walls rather than on the valley bottom, until it has reached this U shape, at which point it can then continue to erode as that U shape.
Muir knew that as a glacier flows, it grinds and polishes the bedrock with rough shards of rock lodged at its base. As they melt and disappear, glaciers leave behind U-shaped valleys and distinctive scratch marks. Muir proposed that giant rivers of ice also once flowed through Yosemite Valley. He hunted high and low for evidence of glacial scratch marks and eventually found a small 20-foot square patch of rock 30 feet from the valley floor.
The granite has scratches on its surface. Each one of these scratches is associated with a rock embedded in the soul of a glacier. I can imagine Muir claiming that this is irrefutable evidence of glacial occupation of the valley floor.
But if glaciers plowed down the valley, why weren't there millions of scratch marks on the cliffs? If Muir was correct, this is a picture of what happened. 2.5 million years ago, the temperature plummets. Yosemite Valley fills to the brim with a gigantic glacier. Only the tallest mountains peak above the sea of ice. For thousands of years, the glacier grinds away at the granite walls, scratching the cliffs and undercutting a peak that will become Half Dome. When it retreats, the glacier leaves precarious slabs of overhanging rock. The unstable rock face crashes to the valley floor. Cleaving the great northwest face of Half Dome. In the same way, subsequent smaller glaciers cut away at the base of the valley for 2 million years, cleaving sheer vertical cliffs and removing all traces of glacial scratch marks. But there was still one glaringly obvious problem with Muir's theory, and arch-enemy geologist Josiah Whitney pounced on it. If glaciers had carved the valley, why was Yosemite uniquely box-shaped and not U-shaped like a classic glacial valley. Whitney attacked Muir's theory and stubbornly declared this square, flat-bottomed valley could only have formed if the bottom had fallen out.
Whitney hypothesized that instead of being carved by glaciers, that this was a fault-bounded valley, with the valley walls being faults down which the block in between the valley walls has dropped. In Whitney's theory, the flat valley floor would be the top of the down-dropped block.
In the quest to unravel the mystery of Yosemite's flat-bottomed canyon, scientists are investigating the valley floor.
The kinds of sediment that I see in this cut bank are coarse grains, pebbles, and sand, the same kind of rocks and sediment that the present stream can carry. In contrast to that, the deposit I see at my feet is very fine-grained.
Light, fine-grained sediment like this is easily carried by flowing water. But when a river hits a body of still water, its energy levels slump and it dumps its load.
This is the kind of sediment that we would expect to see on the floor of a lake.
Further research has found similar strange sediments all over Yosemite. It's proof that 10,000 years ago, an ancient lake drowned this entire valley. Starting at the head of the canyon, it stretched for 5 miles through the landscape. But it was a mystery how Lake Yosemite had formed. Scientists scoured the valley looking for answers, and near the base of El Capitan, at the farthest end of the valley, they stumbled upon an insignificant-looking ridge. It's an important clue to how Lake Yosemite and the valley formed. This mound is made of an unusual collection of rocks, and it runs from one side of the valley to the other.
Given this arc of a ridge is just down from El Cap, one might expect that it could have been caused from a rockfall. But if you look around, that's not the case. Clearly, even in this local area, we have rocks that came from at least 3 different places, no doubt up the valley. This pink rock came from one portion of the valley. This gray granite came from another place. And this particular one, we can see the distinctive feldspars associated with the Cathedral Peaks granite.
This strange distribution of rocks means that the ridge could not have formed from a catastrophic rockfall. Something else, just as epic, must have created it. This is a glacial moraine, the remnants of a glacier which once filled the valley. It's the conclusive evidence Muir had hoped for. Moraines form as glacial ice rips fragments of rock from the valley walls, carries them like a conveyor belt several miles downstream, and dumps the rubble at the mouth of the glacier. Scientists realize this ridge was also key to solving the mystery of how Lake Yosemite and the flat-bottomed valley floor formed. It wasn't just a moraine, it was a giant dam. It's 2.5 million years ago, and glaciers grind through the valley. 10,000 years ago, the temperature rises and the glacier retreats. A huge moraine is dumped at the valley mouth, damming back the icy meltwater. The entire valley floods, creating an enormous Lake Yosemite. Mountain streams spill into this still water and dump ton after ton of fine sediment. The lake chokes with silt, creating Yosemite's distinctive flat-bottomed valley floor.
We know from seismic evidence collected in the 1930s that it's 2,000 feet thick. That's enough sediment to cover New York City by a foot.
And beneath this lake of sediment, they found the evidence that had always eluded Muir. A U-shaped basin, the hallmark of a classic glacial valley. It was indisputable evidence that Muir's intuitive observations and seemingly far-fetched theory were correct. and the final nail in the coffin for Whitney's theory of a cataclysmic rifting valley. Scientists trying to understand how the steep cliffs and flat-bottomed valley formed have found scratch marks, evidence that the sheer cliffs were carved by glaciers, and a glacial moraine, proof that an ancient Lake Yosemite filled with sediment and created the flat valley floor. For over 2 million years, the glaciers whittle away at Yosemite. Then 10,000 years ago, the glaciers retreat for good, leaving the 1-mile-wide canyon we know today. But strange, dangerous forces are still exerting their powers on Yosemite's landscape, with catastrophic consequences. Yosemite Valley has been sculpted by torrential water and thick slabs of ice. But today, another hidden force is shaping this magnificent landscape. It's 6:52 p.m., July 10th, 1996. Yosemite is hit by a catastrophic rockfall. Within minutes, a huge dust cloud of pulverized rock engulfs the valley. News spreads that Happy Isles, the busiest trail in the valley, has been decimated. Yosemite is in a state of emergency.
When I got here, the devastation was really in full force. I saw trees that were just everywhere. There were ambulances, and chaos just was everywhere. People were running around screaming, and the whole area looked like a bomb had gone off.
80,000 tons of rock had suddenly dislodged from the cliff face.
The weight of 1,600 trucks basically fell down. It hit and then exploded, and they created a wind blast.
As strong as a tornado, the wind blast uprooted trees a half-mile away from the impact zone.
We can have about 3,000 people go up and down that trail in one day, and so we did not know how many people were trapped under the trees, and tragically, a young man was pinned by a tree and was killed, and a young woman was trapped under a tree and is paralyzed.
A deadly, mysterious force is continually at work in Yosemite, causing the surface layers of the ultra-tough Yosemite granite to peel away in huge chunks. One large rockfall occurs every week in the park, and yet up to 4 million people visit Yosemite each year, getting perilously close to these potentially unstable cliffs. To discover what's causing Yosemite's incredibly tough granite to fall down, researchers have dotted vibration sensors and solar-powered seismic stations all over Yosemite's cliffs, enabling them to listen to the rocks.
This computer allows me to see what's going on all the time. For example, if I throw this rock at the cliff over there, I just created a mini rockfall. And take a look. And these spikes are the rock hitting the cliff and then tumbling down. This is a mini rockfall that happened right here. So the station will pick up rockfalls that happen that are small right here, but it'll pick up larger ones in other places.
This seismic listening device has pinpointed a recent rockfall behind Half Dome. It's a chance for Valerie Zimmer to investigate why Yosemite's rocks are falling down. And all the evidence indicates another cataclysmic event has occurred.
Oh, look at this. All these trees have been knocked over like they're toothpicks. These rocks range from the size of a house to just dust.
Analysis of the seismic data shows this was a massive rockfall, one of the biggest in the last 20 years. It shook the ground so hard it was the equivalent of a magnitude 2.4 earthquake.
If you look up on that mountain, the amount of rocks that came down, you look up high, it doesn't look like a big area, but it's deceivingly large. It's probably the size of maybe 40 houses altogether.
Strangely, immediately above the scarred rock face, a new dome is forming. Mysterious domes are forming all over the valley. The most famous, Half Dome. Glaciers cleaved its vertical face, but its dome top has been shrouded in mystery. A strange underlying force is sculpting these peaks into domes, causing the rocks to tumble down. North of Yosemite, on the dome at Olmsted Point, it's possible to get close enough to investigate why the surface layers of granite are shattering.
These domes are all over the place. I see these layers running parallel to the surface. They're almost like the layers of an onion. And the layers are starting to peel off. In fact, look right here, this one is coming apart.
The outer surface of the rock has fractured into layers running over the summit and down the sides of the dome.
These are weaknesses in the rock. It's obvious that there must be some sort of force that's causing the rock to break in this way and peel apart like an onion.
The only force capable of fracturing the ultra-tough Yosemite granite like this originates deep within the Earth. 100 million years ago, the Yosemite granite is beginning to form. Submerged beneath 2 miles of volcanic rock, it's squashed and squeezed from every direction. Over the next 40 million years, the volcanic erodes away. The immense downward pressure is removed, leaving these titanic forces out of balance. The surface of the exposed Yosemite granite is now an avenue through which this pent-up pressure can be released.
The granite is still being squeezed from the sides and from the bottom, but at the surface it's free to move. What happens is these layers start to open up, parallel to the surface.
The release of this ancient pressure causes the surface of the granite to fracture into onion layers, which then peel away.
And so when the tops of those mountains fall off, you're left with rounded domes.
But it's not just the granite peaks that are affected. It's the cliffs, too.
These layers will also form if the ground surface is vertical, like a cliff, creating vertical fractures alongside the cliff. These vertical fractures allow the rock to then slide out and create rock falls. And this is one of the major contributing factors to rock falls in Yosemite.
Yosemite's catastrophic rock falls are the legacy of its prehistoric birth beneath the earth 100 million years ago. The gradual release of this ancient pent-up pressure has created an untamed and dynamic landscape.
Rockfall is a natural process and is part of the ongoing evolution of Yosemite National Park. I always get a little bit tickled when people ask me questions like, what are you going to do to prevent future rockfalls? It's a constant reminder that this is a wild place and that there's nothing we can do or should do to tame it in any way, shape, or form, but it's something that after I'm long gone will continue to happen.
For the last 150 years, scientists have been figuring out how this magnificent valley formed. They found volcanic rocks, proof that the molten granite cooled deep beneath the earth. Large crystals, evidence that Yosemite granite cooled slowly, creating tough, faultless rock. Rapids downstream show that the Merced River cut a deep V-shaped canyon. And rocks carried by a glacier, conclusive evidence that ice carved Yosemite's steep cliffs and flattened its valley floor. Yosemite, a valley of giants, is a geological masterpiece. The unique strength of its near-perfect granite has created some of the most imposing and iconic landscapes on planet Earth. One where the deep earth forces that created it are continuing to shape its future. Living proof that the Earth is never at rest.